Good morning. Today we will be going through two concepts, arc length and sector area. Okay, we're going to first start with writing down two different formulas. One of the formulas is calculating arc length when they give you theta measured in degrees. Okay, so if you are looking for arc length of a circle and the theta measure, so the angle measure that they give you is measured in degrees, you are going to then use this formula here. Arc length equals theta divided by 360 times 2 pi r when theta is measured in degrees. If they give you theta measured in radians, then you need to use this formula here. Arc length equals theta times the radius. Okay, two different formulas, each calculating the same thing, arc length, but one is used when theta is in degrees and one is used when theta is given to you in radians. Okay, let's practice. Number one says find the length of each arc. So we're calculating the length of the bold arc. So we are given the measure as 315 degrees, and we are given that the radius is 11 feet. So we're going to calculate arc length equals 315 divided by 360 times 2 pi, and then times our radius, which is 11. Okay, I'm going to calculate it two ways. I'm going to leave it in terms of pi, and then I'm going to round to the nearest, we'll say hundredths place. Okay, so first, 315 divided by 360 gives me as a fraction, let me hit that, 7/8. And then I'm going to do 7/8 times, let's see if I go back, 11 times 2 is 22, so times 22. Okay, as a fraction is 77 fourths. So in terms of pi, the arc length is 77 fourths pi feet. Rounded to the nearest hundredth, I'm just going to take 77 fourths, multiply it by pi. Yeah. Okay, multiply it by pi. Whoops. And we get 60.48 approximately. Okay, so we'll go approximately 60.48 feet. Okay, next one. This time we're given the measurement of theta in radians. Okay, so let's change colors. Arc length, because it's given to us in radians, we're just going to do the radius times theta in radians. So theta times the radius, 3 pi over 2, which is going to give us 16 times 3, which is 48, divided by 2 is 24 pi feet. So that's the exact value. Now we'll go ahead and put it into Desmos and get an approximate calculation, rounded to the nearest hundredth, 24 pi, 75.40 feet. So approximately 75.40 feet. Okay. Next question says, the length of arc EF is 5 pi inches. Find the length of the radius. Okay, so they actually are giving us the arc length here. Okay, they are giving us that the arc length is 5 pi. I'm going to take my theta measure, which is 30 degrees, and I'm going to use what we learned on our first lesson, which was conversion from degrees to radians, and I'm going to make that measure into a radian measure. So I'm going to go 30 pi over 180, which would give me pi over 6. So this measure here is pi over 6. Now I'm going to use the arc length formula. Arc length equals theta times radius when theta is given to you in radians. We just converted it. So I'm going to say 5 pi equals pi over 6 times r. Okay, I'm looking for the radius. I'm going to get r alone, divide both sides by pi over 6. Okay, go to Desmos, 5 pi divided by pi over 6. Oops. And I get an r value of 30. So r equals 30 inches. Okay, let's keep going. A circular spinner is divided into 15 equally sized different colored sectors. The spinner is 6 inches in diameter. What is the arc length of one sector of the spinner? So I'm going to take my circular spinner, and I know a circle is 360 degrees, right? So I'm going to take 360 and I'm going to divide it by 15 because that will give me the theta measure of each individual sector. 360 divided by 15 means that each sector is 24 degrees. Okay? Each sector is 24 degrees. The spinner is 6 inches in diameter, which means that the radius is 3 inches. To find the arc length of one sector, I'm going to go degree over 360 times 2 pi r. And I'm going to put that directly into Desmos, round my answer to the nearest hundredth. 24 over 360 times 2 pi times 3, which gives us 1.26 inches. That's for the arc length of one sector of the spinner. Okay. A merry-go-round rotates 2,808 degrees per ride. How far would a rider seated 8 feet from the center of the merry-go-round travel during the ride? So we want to know the arc length that the person riding would travel. So I'm going to use 8 feet as my radius, because it's 8 feet from the center. And I'm going to do the arc length formula with the degree measure. 2,808 over 360 times 2 pi times 8. And my answers for units is going to be in feet. I'm going to stick it directly into Desmos, exactly the way that you see it. 2,808 divided by 360 times 2 pi, and then our radius was 8 because the rider was 8 feet from the center. 392.07 feet approximately. Okay, let's keep going. I think this is two more. An intercepted arc has a length of 19 yards. If the radius is 4 yards, find the measure of the central angle in radians and degrees. Okay, so we are given again the arc length, which is 19. We are given the radius length, which is 4 yards. Let's first find the measure of the central angle in radians. So we're going to use the arc length formula. Arc length equals theta times radius. Arc length was 19 equals theta times our radius was 4. Divide both sides by 4. And that gives us a theta measure of 19/4, which is 4.75 radians, or we can leave it as 19/4. But I'll just go ahead and just put 4.75 radians. Okay, let's do that same, using those same values to find the measure of the central angle now in degrees. Okay, so in degrees. So we can actually, instead of going through the whole formula again, because we have the theta measure in radians, we can just go ahead and use what we learned a few days ago, where to convert a radian measure to a degree measure, we multiply by 180 divided by pi. So let's just go ahead and do that. Theta equals 4.75 times 180 over pi. And remember, that's the conversion to go from radians to degrees. We go straight to Desmos. 4.75 times 180 over pi. And we get a degree measure of approximately 272.15. So theta in degrees is approximately 272.15 degrees. As a radian measure, it's 4.75 radians. One more with arc length. This is the first year Janice is playing softball. She has been practicing her batting. On her last swing, the bat made an arc with a radius of 48 inches and swept through 255 degrees of rotation. Assuming that the arc is circular, what is the distance that the tip of the bat travels to the nearest inch? And how many feet is this rounded to the nearest foot? Okay, so we're looking for the distance that the tip of the bat travels, which is essentially arc length. We're given the measure of theta in degrees, so we're going to use the formula. Arc length equals 255 over 360 times 2 times pi times our radius, which is 48 inches. We're going to calculate that in Desmos, and that will be our arc length in inches. And then, of course, they want us to determine how many feet that is. So we take our inches and we divide it by 12 because there are 12 inches in 1 foot. So we stick this into Desmos. 255 divided by 360 times 2 pi times 48. So this is 213.63 approximately. Let's go 628 because we're not done yet. So 213.628 inches the bat travels. take that value, divide it by 12, and we'll round that to the nearest foot. Which gives us approximately 18 feet. Okay, let me just make sure that if we had done 213.63 divided by 12. Yes, okay, good. Okay. Oh, there's one more arc length. Oh no, there's a couple more. That's okay. Okay, an arc length of 47 centimeters subtends a central angle of 5 pi over 4. Find the radius to 2 decimal places. Okay, so again, we are given the arc length. We're given the central angle in terms of pi, 5 pi over 4, so that's a radian measure. We need to find the radius this time, so we're going to use arc length equals theta times radius. We know the arc length is 47 equals 5 pi over 4 times r. To get r alone, we divide both sides by the theta measure in radians. We go straight to Desmos. 47 divided by 5 pi over 4. Let me put 5 pi over 4 in parentheses just to keep that together. 47 divided by 5 pi over 4 gives us a radius length of 11.97 centimeters. That's our R value. Okay. Next one, a carousel in an amusement park rotates 3,024 degrees per ride. How far would a rider seated 13 feet from the center travel during the ride? Okay, so very similar to the merry-go-round question. A merry-go-round is a carousel. So the rider is 13 feet from the center. That's our radius length. We know that they are rotating through 3,024 degrees. So for part A, we're going to go 3,024 over 360 times 2 times pi times 13. And we calculate the arc length, which tells us how far the rider rides on this particular carousel. That looks like a B. Let me fix that. Okay, so we're going to go to Desmos. 3,024 divided by 360 times 2 times pi times 13. We get 686.12. So approximately 686.12 feet. Part B says, how much farther would a second rider seated 18 feet from the center of the carousel travel during the ride than the rider in part A? So the carousel is still rotating the same amount of degrees, except what changes this time is our radius, because the second rider is 18 feet from the center. So for part B, let me change colors. 3,024 divided by 360 times 2 times pi times 18. We put that into Desmos. I'm actually just going to delete 13 and put 18. And we get 950.02 for this rider in part B. And to answer the question, how much farther does the person ride? We take 950.02 and we subtract our answer from part A, which was 686.12. And so the rider goes approximately 263.9 feet further. So to answer the question, let's use orange. 263.9 feet further. Okay. Okay, two more important formulas that you're going to need to write down deal with area of a sector. So we just covered extensively arc length, which is the distance around a certain portion of the circle. Area of a sector is going to refer to the space taken up by a specific shaded region. We have two formulas again because theta can be given to you in either degrees or in radians. If you are given theta in degrees to calculate the area of the sector, you're going to do theta over 360 times pi r squared when theta is in degrees. If theta is given to you in radians, you can use 1/2 r squared times theta. Okay, so make sure you take these two formulas down just like you did for arc length. Okay, first problem says calculate the area of the sector. The sector theta is given to you in radians, 2 pi over 9. So we're going to use A equals 1/2 r squared times theta. We're going to plug in 1/2. Our radius length is 18. Our theta is 2 pi over 9. Just like I did with arc length at the beginning, I'm going to give you the answer in terms of pi, and then we'll calculate it out to the nearest hundredth. 1/2 times 18 is 9. 9 times 2/9 is 2. So the area in terms of pi would be 2 pi meters squared. Area is always in units squared. We go to Desmos and we just simply calculate the value of 2 pi rounded to the nearest hundredths, 6.28 meters squared. Again, if that first part was confusing, all I did was do 1/2 times 18 times 2/9. 1/2 times 18 times 2/9. And I got 2. Okay, 2 more and then we will be done. Number 15. The shaded region is 215 degrees. The radius length is 4.5 yards. So we're going to use A equals theta over 360 times pi r squared. 215 over 360 times pi times 4.5 squared. Let's find our value in terms of pi, and then we will calculate it out. So we're going to go to Desmos, 215 divided by 360, and then times 4.5 squared. We'll put it as a fraction. I'm going to hit the fraction button. 387 over 32 pi. 387 over 32 pi yards squared. And then we'll calculate it out. So I'm just going to compute using pi. 387 over 32 pi, which gives us 37.99 square yards. Okay, last one. We are given our shaded region. We want to calculate the area. This time our theta is in radians. So we're going to use our formula A equals 1/2 r squared times theta. because theta is in radians, 1/2 times 21.4 times 21.4 squared times 13 pi over 18. To compute just in terms of pi, I'm going to plug in 1/2 times 21.4 squared times 13/18. I'm not going to use pi in my first calculation. 1/2 times 21.4 squared times 13/18. Ooh, wow, that looks terrible. 148,837 over 900 pi. Meters squared. And then to calculate out to the nearest hundredth, we're just going to multiply that by pi. And we get approximately 519.54 square meters. Okay, that is it for today. Thank you.